Hi everyone, welcome to the series Let's Get Solving with Google Cloud. My name is Ajinkya Kolle. I'm a data engineering and machine learning instructor at Google Cloud. And this is the session in which we are going to build web applications which are scalable. But in this time, we are going to do that on Kubernetes. In the seventh session, which was the last time, we did the same thing on App Engine. So on App Engine, what you did, we focused just on the code. Okay, we did App Engine standard, wherein it does not have custom libraries. So it's like we used a Python code. We kind of like deployed. I don't know whether, I don't remember if we used data store there, but that kind of like builds a complete scalable thing, wherein no matter how much performance is needed, App Engine kind of like scales to that. Now we're going to do the similar thing, but instead of App Engine, we're going to use Kubernetes. What does Kubernetes help us to do? Kubernetes nowadays going forward has actually become one of the popular ways because it's cloud agnostic. You see, if I develop an application and I can move that application between any cloud or even maybe my on-premise or maybe from on-premise to on-cloud without much problem. That's amazing flexibility, right? So this is what we actually have when we build this application with help of Kubernetes. This is what we are getting. So even though Kubernetes might be complex, but after we get used to it, it becomes easier. But the advantages it actually gives us, they are quite powerful. Okay. So I would recommend, this is the last time that I would recommend you to go to this link, create the account, take the advantage of this free 1 month pass to do all the labs which you can, because the knowledge which you build, which is just theoretical, is very shallow. It's not gonna scale to a practical situation. We are all developers. We are not thinkers. This is not a think tank where we are just thinking about, oh, I wonder if I solve this, how could I do that? No, we are actually building the stuff. So to do that, we have to actually develop the stuff. So where do we practice? We practice it on Qwiklabs. So I really urge you, this is a very good opportunity because otherwise you might have to consume, let's say either a bill on Google Cloud Platform or the free credits which you have to get. So I think this is much easier if you do this, but it's up to you. Okay, this is the Qwiklab thing. So here you actually find the lab you're interested in, and once you find the lab you're interested in, you click on Start Lab, copy paste the username and password, go into incognito window, go to Google Cloud Console, of the Google Cloud Platform, use those username and password to log in, and then we start the lab. Okay, so this thing we have talked about in all first 7 videos. So it's like, sorry if I did not do that, take that in detail this time. Okay, anyways, so the lab which we are going to do is deploy, scale, and update our website on Google Kubernetes Engine. Okay, so before we actually go on doing this lab, so the lab is this. Okay, this is the deploy, scale, and update your website on Kubernetes Engine. Before we do that, I just want to share a few links, and a few links which in my opinion are very interesting on Kubernetes. Okay, so if you want, maybe let me just zoom in. Okay, this is enough. So just pause the video, take photo of this QR code, and this should actually open this link, which is the one tab link. And in this one tab link, it's kind of like 12 links on Kubernetes which are very interesting. My most favorite link is this one, Illustrated Children's Guide to Kubernetes. So, so this is just amazing. I mean, the person who came up with this, it was such a mind-blowing approach to actually do that. Amazing. A 8-minute video which gives a very interesting, very easy to understand foundation basics of Kubernetes. And in same thing, there is another video, Kubernetes story, a Philip goes to zoo, and these two are actually kind of like very useful things. They start from a very no knowledge of the Kubernetes, and then slowly build your conceptual intuition. Then we have few links like this, Kubernetes 101, Kubernetes 110. We have Kubernetes best practices. We have Kubernetes day one. So these links again, they kind of are trying to build your knowledge from ground up. It's like if you're new to Kubernetes, this is what you should be actually going through. If you want to do hands-on lab, then Kata Code is a very good website to actually know. Here there are lots of labs. How many? So 4 labs, 4, 8, 12, 16, 20, 20. Okay, 20. We have around 20 labs on Kubernetes. They are very comprehensive. You can execute them directly here in the browser. You don't need even Qwiklabs if you are executing these labs. It's very useful. Okay, so anybody who is in charge of maintenance of a website, for example, let's take this website. Okay, if let's say a person who is maintaining a website, they want to make their infrastructure in such a way that it can scale to whatever demand it might come in future. We actually have to have our development environment, our platform is like organized or structured in a very nice manner. Actually, cloud is providing us exactly that, because cloud is providing us managed products. We can host our application on those. But if I want to do this thing with help of Kubernetes, I can do that on premise as well. That's the fun part. Okay, so we have these few interesting links, and this link is also interesting, Survival Guide to Containerizing Your Infrastructure, because going forward, you see, anything I containerize, it becomes a different way of scaling that application without much management from the developer side, DevOps side. So if it is possible, containerizing the infrastructure and developing the website or application as a microservice, not monolithic, but microservice. Okay, so when we do it in a microservice approach, that's when it's extremely easy to scale it, and even it is very flexible in a way we could code an application. So for example, let's say I have an application in which there are, let's say instead of having one big application, I make it 7 components. Okay, 7 components. I use 7 word a lot because Harry Potter Horcruxes. Even my password contains word 7 quite a lot. So it's like 7 Horcruxes, Harry Potter. Right? It's my favorite number. Anyways, let's say I have a application which I have divided into 7 microservices. So what I could be doing is, let's say I have a team which is doing one component related to payment, and they decide I want to do it in Java. No, they're free to do that. Somebody else who's like, let's say they are Python guys, they decide to do that component in Python. They're free to do that. Somebody could do that in C sharp, somebody else could do that in one component in C, C++, anything. Because in microservices approach, each microservice is independent with each other. They just communicate with each other through the agreed upon API or whatever the way they have agreed to communicate. But other than that, they are free to choose their library, free to scale independently. So it could happen that out of the 7 components which I've had, only one of them is compute intensive, rest are not. So I don't have to allocate one powerful server to all the applications in one. I can just choose that, and I can be specific for just one thing. I could also kind of like have, they could scale independently because they're microservices. So this microservice approach instead of monolithic approach is becoming quite popular now. And Kubernetes allows us to helps us to do that. So these are the kind of like few interesting links. I would recommend you to do that. And now you see, I've been mentioning that labs are actually quite essential because they're actually going to build more technical hands-on knowledge. So if you don't have the hands-on knowledge, then it's like I don't think you'll be able to actually do or troubleshoot the problems you face while actually doing and solving a problem. Okay, so for that purpose, I would recommend this is the lab. Quite complex, not that complex, but anyways, it's an interesting problem statement which we have here. Okay, so what we are going to do, we are actually building a website, and we are actually deploying it on Kubernetes engine. We are going to scale it on Kubernetes engine, and we are going to update it on Kubernetes engine. So 3 different problem statements we're actually solving here. Okay, so let's just start with this. And the application diagram, oh, this I can't zoom. Let me just open it in new tab, and let's go here. Okay, so let's take a look at the bottom half part of the diagram. Okay, in the bottom half part, we have created a Kubernetes cluster. There is a cloud load balancer here. The cluster has one external IP through which then the load balancer decide where should the traffic actually go. Let's say if one of the nodes is, am I speaking too fast? I'll try to slow down. Let's say load balancer figures out that one of the nodes is very busy. Load balancer will actually try to distribute the workload across the remaining ones. So this is how kind of like the load balancer, which is part of the Kubernetes engine, it's quite intelligent there. Okay, it's part of the Kubernetes. This load balancer in the red, it's quite intelligent. Okay, this Kubernetes engine cluster, when a service we have deployed, it's available via one external IP. So we have this, multiple nodes running. If we take a look at the top half part of the diagram, it could be that, let's say I have created a website. I want to, deploy a next version of the website. I want to do that next version. I want to test on the small subset of the population, and I want to do monitoring. And if, everything goes well, only then I want to deploy it to something else. I want to do that. I can do that. Okay, so all of these things we can actually easily do with kind of like with help of Kubernetes. So in the developers kind of like crowd, doing continuous integration and delivery is an integral part of being DevOps. What is continuous integration? It's like if I commit a code on GitHub or somewhere else, it's like I'm gonna run my testing suite, which is regression testing or some other testing automatically. I have to have my code coverage, which is pretty accurate, and then once it is successful, I'm gonna immediately integrate that into image, build the image, and deploy that image. That's continuous integration and delivery. So it's completely new paradigm, kind of like goes in hand with the agile way of developing. We have a sprint which is gonna last a week. We are gonna have few small kind of like code sprints of individually they're gonna do those features, and at the end of the sprint it kind of like gets deployed at the weekend. So every week we are having more features, and the product is slowly progressing towards a milestone, which could be alpha or new feature or something like this. So Kubernetes kind of like ties in very well with that all the work a DevOps person has to do, or it also ties in with the work of site reliability engineer, where they have to maintain the reliability of the application which is being deployed somewhere. Right. So let's go back to the lab. The lab is deploy, scale, and update your website. And here it's kind of like divided into 5 major components. One, create a cluster. Two, create a Docker image. Three, deploy a Docker image. So first three are really easy. Okay. Then final two are actually more important. It's like scaling the application on Kubernetes and then performing rolling updates on the Kubernetes. Okay. So let's just go about doing that. This is the setup. We are going here, activate Cloud Shell, and okay, so this is where we actually have to start the lab, setting up our default compute zone. If I create a cluster, I wanna create a cluster in certain zone. This is the kind of like right choice. So I've already logged into my Google Cloud account, not into the Kubernetes thing, because I'll have to do the go into incognito window. I have my Cloud Shell open here, and I'm copy pasting this, setting up my default to US Central 1F. Okay. Then let's scroll down, create a GKE cluster, and we are enabling APIs. So APIs are enabled. You could either do it through UI, wherein I search Kubernetes API here and enable it, or I could do it using command line. So it's like if you're a Linux guy, you'll do it through command line. If you're a UI guy, you'll do it from here. But it doesn't matter how you do it. It just matters that you do it, right? So we are actually doing this. We have executed this command. This is creating a cluster whose name is fancy cluster. Okay. So let's just wait for that fancy cluster to be created. It should take maybe a minute or something. And when that is created, it is going to contain 3 nodes. Meanwhile, those nodes will be created in our compute engines. So if I go into my compute engine, if I look there, I should actually see those cluster this thing. Oh, I'm not actually seeing them here. I should. Okay, let me refresh. Refresh. No? Wow. Cluster is being configured. I don't know how long we'll have to wait. I think I'm hurrying too much. Let's just wait. Let's just give it some bit of time. We should see virtual machines here. Then they'll be configured. And once they'll be configured, the cluster will be created. Okay. So let's just wait for that to happen. Okay, let's see what happened. This thing is done now. Okay, it took a bit of time. Yes, so fancy cluster is this, location is US Central 1F, master version is this, IP is this, machine something, and 3 nodes, and it is running. Okay, so this is only the part of cluster creation. Okay, we have already seen in compute instances we have the clusters which are these 3 nodes, and rest of the machines I have created for my own sake. Let's just scroll down. This part is done. I have not actually done this with help of Kubernetes, sorry, with help of the ID present in this lab. Otherwise I would have been able to check my progress. For now, let's just do git clone thing. Let's just start executing this code, which is our microservice code. So this thing exists already. So I already mentioned monolithic was one big application, one code, everything in one. Then microservice was kind of like this approach wherein we divide that into individual components. Okay, they scale and coded independently. Okay. Now, when we scale and code them independently, for each microservice, I actually deploy it on Kubernetes cluster by containerizing it. What is a container? Container is nothing but a box. Okay. A box of a place where it is going to run. Okay. So let's say I have a code, I was a website, I put it on a container, and that code is kind of like the Docker image, and I run that Docker image as a container on a cluster or something. The cluster here is Kubernetes cluster. So Kubernetes is, I think, Greek Latin name of this thing, but that word, that name, it means captain. So like whenever I see captain, it reminds me of Captain Jack Sparrow, Pirates of the Caribbean, one of the coolest captains of all time. Definitely. So it's like, what's the role of the captain? It reminds me of the movie 3 where he's stuck in Davy Jones' locker and is like he's trying to pull his ship, and the ship is carried away by millions and millions of crabs on their back. Okay, so you see, the crab was a good example of distribution. If I have to move that huge ship, I don't know which movie, I think it's movie 3 only, where his ship is carried into the sea with help of those crabs. If I had to use one vehicle to carry the entire black pearl, that vehicle would have to be very powerful. The alternative was distributed computing, wherein you have small crabs but in a large number. Okay, so you see, this is exactly how even a cluster is actually running. On a cluster, we are running containers. Okay, and the containers can be run as many as we want, which are part of the cluster. So it's like with help of containers, I can scale a lot. So Kubernetes, which is the captain, it is going to be managing all the containers in the cluster. So that's how it is actually created. So either you can watch this illustrated children's guide to Kubernetes, or you can refer to my Captain Jack Sparrow analogy and understand what Kubernetes does. Okay. So the code is there, and we have to kind of like, let's just set up this thing. So I'm going into the CD code. Let's just set up this thing. And it is setting up the NPM versions and something. Okay. So it's like dependencies all are getting set up. Okay, fine. Let's just scroll down. Once the package is there, we actually start the package, and we actually, our monolithic application is done here. Okay. So the dependencies and something. So let me just copy paste this thing as well and be ready to go there and actually start executing when this thing finishes. Okay. So let me just see. Is there any relevant thing which I could show? I think design patterns would be a good link to go. This is a very good link. Anyways, going here, let's just execute this. The monolithic thing is listening on 8080. So a preview on 8080. It's going to be a simple web app. Let's just see what this is doing. Surprise! So this, wow, this is so zoomed in. So we have the fancy store. If I go to products, we have, these many products which have been kind of like created here. Ooh, vintage typewriter. Ooh, terrarium. I love terrariums. It's just amazing. I mean, one time I was looking for a gift for my friend. Like I had found out on Etsy a terrarium earring. So Terrarium is kind of like this enclosed ecosystem, okay? And it's just amazing. So it's like a biosphere, and you actually have everything contained in that. And those were Terrarium earrings. So we have some bit of moss there. Just amazing. So I love Terrarium. So scrolling down, we have air plant, metal marks, and it's like if I put some orders, some bit of orders here. So as you can see, this is quite a fancy application, like yes, last time where it was just hello world and how you doing. That was the last application. Okay, so the monolithic application has started. Now let's just kind of like see. Okay, this is asking us to stop this thing. Okay, I'll stop. It is asking us to stop. I'll stop it. Now let's create a container here. So cloud build APIs. I don't know whether I need to actually do this or not, but doesn't hurt, right? Anyways, so this thing is the submitting one. Okay, so we actually create an image, we create a build, we build our code, and then kind of like that code is builds the image or something here. So this thing is done. We are executing this, and let's just wait for this to complete. And this is going to build the image. So this is going to take some time, and when this is completed, we get a image which is created. So you see, if I create an image, that image is actually uploaded onto my Google Cloud Console into the registry, which is what this command is actually doing. Okay, What is this command doing? It's creating this on Google Cloud project. So this gcr.io. So this is the registry of all the Docker containers which I could be creating or will be creating inside my project, or I could share them very easily. So this is a Docker repository. This is amazing. Okay, so this is the container registry. Lots of features here. We can do tagging, deployment, blah 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 blah. So let's just wait for this thing to finish, and then we would have actually had image which we have successfully uploaded onto Google Container Registry. Okay, it did something, it is executed, and the image has been created. So in the checklist of these three things, the image is now done. So we are going to go and we are going to actually see this thing. So the image is present somewhere, and that's fine. Okay, now is the deployment. Okay, and the command is kubectl. There are a few autocomplete for Kubernetes command line. Maybe you can Google that, and they can actually help you execute Kubernetes commands faster. But for now, let's just kind of like stick to the basics thing. Like I said, Kubernetes is hard at the beginning. If you go to this code, kata code, you can actually, go and check and execute few of the introductory Kubernetes things that should give you hands-on knowledge of Kubernetes, and you'll find this much easier. So here, for now, we are creating a deployment with help of this image, and it is to be okay. So this is using that deployment, and which is like image, and that image is actually being taken, put on our cluster, and that's the job of the Kubernetes, right? What is Kubernetes jobs? It is a container orchestration system. It is the captain of the containers which we have put to here. So the container was this image which was in gcr.io, and this thing deployment has been created. Now we'll actually see, with help of these few commands, we are going to get details of whether how the deployment is created, what's the IP, and blah 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 blah. Let me just increase this thing here. Oops, I need to zoom out so that I can see that in one thing. Okay, so kubectl get all I've done. Pod is this monolithic, ready, one running, age is 32 seconds. Service cluster IP is this, external IP none. Deployment monolith up to date, available one, and ready and something. Okay, so fine, it's on this thing. So deployment, this is the current deployment. Then we have replica set, which is one, and pod is the place where it is running. If you go to this document again in Kubernetes 101, you will see, cluster, container, node, and pod. What is the exact meaning on this with help of Kubernetes thing? So you should actually go to this. Okay. So you see navigation menu, Kubernetes engine, and workload. We could do that. This I did not do last time. Stick to command line. So maybe I should do this now. So scrolling down, Kubernetes engine, workloads. So here in the workloads, we should actually see the workload. This is the monolithic thing. This is the deployment. Okay. And there are lots of commands. You see, it's like kubectl describe and something, deployment, blah, 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 blah. So it's like it gives you all the details. So you see, Kubernetes is the auto-healing, SRE. What happens when we delete something? What happens? What should it do automatically so that this thing does not actually fail? That's the job of Kubernetes. So this lab is asking, delete something, see what happens. Disturb something, see what happens. That's the in kind of like Hindi we call it kida. So it's like kuch keede karte hai, So let's do some kida. Let's just delete the pod and let's see if Kubernetes handles it. If it does, then awesome, right? So we won't do that. This is gonna, something is gonna get terminated, then something is gonna, get replica, and replica this thing. Replica ensured that whenever if it was deleted, it immediately picked up alternative, and this thing whatever was required, that thing was set up. We actually met that demand automatically. Something was built up, and the actual available computational resources did not change. Okay. So we created deployment here. Now we have to expose it to the publicly thing so that it is accessible. So we are exposing the deployment here. So this is the command. Again, kubectl, right? So then kubectl expose deployment, the monolith, the load balancer, port, target port, blah blah blah, and it's like instantaneous, right? There is no deployment is already done. It's just the IP thing now. So if I execute this kubectl get service, so this command is executed quite a lot to get external IP. I think I'm again speaking fast. I do that when I get excited. I think in machine learning, I must have spoken very fast. I got very excited when topic is machine learning. So this thing is gonna this thing is gonna take some time, and we are gonna see external IP. And when we see the external IP, that's the kind of like IP which will be used for the website, and it's gonna be running on Kubernetes. So it is there on the external IP, and I forgot what was the IP which we exposed it to. So I think it's 80. If not, I'll check it. So what's the port? This thing. So once you this thing, check application is accessible. What's happening? Why it's not executing? Let me. Oh, that's the load. No, correct. Cluster IP, external IP. This was the correct IP, and the port is 80. This thing. That's also correct. Maybe HTTP and then something. Oh, it was anyways coming there. I should have waited. So it's the same thing. Nothing is changed. We have containerized it and we have run it on Kubernetes. What has changed is if in the background something fails, it's not gonna matter. Kubernetes is going to do everything in its power to ensure that it is up and running without any issues for us. Okay. So that's the kind of like this thing. And we have the scaling part, which is here. So just this command kubectl scale deployment, and we increase the replicas. Initially replicas was 1, that's what were used when something failed. Now we kind of like make the replicas as 3. Now what happens if we execute this command get all? This should actually get us details of what's happened in the background. You see we have load balancer and the replicas. You see replicas are available as 3 here. Before when we executed it would have been 1. Simple command, we have scaling done. That's how easy it is to scale. Okay, so it's like, and if we make some changes, if we change something, and this is the kind of like code change here, and then we have to go through the same thing. We have to build the code, then we have to submit the image, and kind of like this thing. So after we update the image, okay, so what I'm going to do is I'm going to simply do the copy pasting. So it's like we are doing the code change here. Okay, so I'm copy pasting this. We have changed one JavaScript, and the code is there, some bit of code change, and then we are actually creating npm build of the website, which is new. So npm build is done. Okay, and once the npm build is done, we want to actually build a new version thing. So npm build is done. Let's go to the monolith thing, and submit the 2.0 image. Okay, so you see what we are doing, we are upgrading our website, not the software but the code of the website. So we have created a new image, again like previous one we had, but this image is the monolith 2.0, not 1.0. Okay, and now we are actually going to upload this on with zero runtime, and this is the part which again Kubernetes figures out. It figures out which one to shut down, how to upgrade, and it's like all the everything is done. So it's like if something gets deleted, something gets destroyed in the nodes of the cluster, it auto heals. It also automatically scales. All of this thing is part of Kubernetes. The App Engine also does that, but just in the background. Kubernetes, it does in the foreground. We have some bit of control over it with help of kubectl command, but it's platform independent, cloud independent. It gives us a lot of control. It's good for the DevOps thing. So it's like, sure, a bit of complex, but that's okay. Okay. So once this thing is done, we are going to actually execute this thing. So pushing the image gets pushed, and layer is already existing. So I think we are almost towards the end. Okay, fine. So copy paste here. Deployment is set. Okay, and simply this thing, I'm copy pasting this command and let's just see what happens here. This is fun. Okay, so this thing is running. Let me execute it again. Okay, it's again running now. It's again running now. It's, oh, it should be having this thing, where uh, I think it immediately, did I do kubectl set? Yeah, did. Was this 2.0? Yes. Oh, it is happening right now. So it's like the old ones, they were having, the old version code. So right now, what has happened is like it is terminating few running kind of like pods one by one, and after it is terminating them, it is going to upgrade them. It is going to run a new thing there, and new ones are going to run. So you see, all these are terminating. These three are running. If I scroll down, there were these three. You see, we had three replicas, so three were running here. Now here also we have the same thing. Three are running. These are the new ones. These are the old ones. Zero runtime. Wait, sorry, not zero runtime. Zero downtime. Okay, that's Kubernetes. So I could be having continuous integration, continuous delivery pipeline, automatic this thing, automatic upgrade. Maybe I could, do A/B testing. I could be doing, it's a different kind of like deployments. Anything. Kubernetes is extremely powerful. Okay, it is extremely powerful. It's complex as well, just to say that, but it is definitely a very good product for DevOps, and I would recommend, like if you're from any admin background or something, Kubernetes is very good to know. Now in machine learning, we have this thing which is coming up as a future, MLOps. So if you actually simply Google on, even you'll find the MLOps on Google Cloud blog as well. So this is the continuous integration and delivery and automatic this thing pipeline. And we could do that with Kubernetes. So Kubernetes is also part of here. So it's called as QFlow. So this DevOps, MLOps, all of these things, this is actually part of the product of a ML thing. So this is actually pretty important. So you see machine learning, DevOps combination, and also data engineering. So it's like I teach data engineering, I teach machine learning, I don't teach DevOps. So it's like MLOps is a bit behind, besides my area of expertise. Anything except this part, maybe you could say that. But this is very, very important. Okay. So like do check it out. Do check it out. You could also do QFlow Lab if you want. Simply do some extra labs on Kubernetes, which you can find on this thing, which is a 1 month free access which you are going to get. So please do that, and it's going to be very interesting. Okay, so let me just simply search Kubernetes here and show you how many Kubernetes labs we have. So 96. Okay, that's too much. Too much. Anyway, so we have 96 ones, so do whatever you want. And yeah, it's like I had fun delivering these things. Lots of movies references. I hope you learned. So we have covered in a comprehensive manner from infrastructure modernization, data modernization. Then after data modernization, we did machine learning, and now we did app modernization. I hope you enjoyed the journey, and we have solved 8 problems with Google Cloud, and we have learned it. Thanks a lot for listening. Thank you.